Everyone, welcome back to my channel once again. So in this video we are learning about electron transfer reactions. After learning the electron transfer is nothing but transfer of protons. So let's know about how these electrons are transferred, and yes, they are having a speed. Okay, the release of speed, the release of speed, like each and every metal shows its unique speed. So according to that, you can say which is the more acidic and which is a less acidic. So here, when you put a metallic strip of zinc, or you can say zinc metal, in an aqueous solution of copper nitrate for about 1 hour. You can see in this picture, zinc rod placed in a copper solution, that is copper nitrate solution, which already initial state you can see it is in blue color. Okay, but when the intensity of blue color is reduced, okay, now you can see in the intermediate stage, that is the stage in between the first stage and the final stage. So that is the intermediate stage. So here you can see the little bit disappearance of blue color of copper nitrate solution. Okay, so now here, after after deposit when you deposited as a copper, where finally Cu plus 2 is deposited as Cu, means it get reduced due to zinc. Okay, but here I wanted to add, when you pass H2S gas from this colorless solution of having zinc ions, the last picture you can see, the solution become colorless and the metallic rod which has the zinc rod, it becomes red in color. That means there are ions of zinc on the ions of copper on zinc rod. Okay, so when you pass H2S gas in this solution, there is a formation of, due to these zinc ions, there is a formation of zinc sulfide. Okay, there is a formation of zinc sulfide, means there is a transfer reaction of replacement reaction, that is H2 is replaced by zinc, that's why it becomes zinc sulfide. Okay, so it means zinc has lost 2 electrons and it becomes, you can see in this picture, this reaction we can write it as, see the second reaction, zinc solid plus Cu plus 2 in aqueous form, it becomes zinc plus 2 in aqueous form plus Cu solid. So here you can see zinc releases 2 electrons and becomes zinc plus 2, and copper plus 2, which gaining the 2 electrons from the zinc, it becomes copper solid. So here you can see zinc has lost 2 electrons, that's why it becomes zinc plus 2 ion, and therefore zinc is oxidized. And evidently here we can see, as zinc is oxidized, so someone is reduced. Which one? That is the copper. So copper ion is reduced by gaining 2 electrons and become copper. So now let's recheck this equilibrium by putting a strip of metallic copper in zinc sulfide solution. So when you do this reaction in the laboratory, you can see there is no any changes in the solution and there is no formation of cupric sulfide. So this means the state of equilibrium for this reaction greatly favors to the product over reactants. Okay, so let's see the next case. Okay, if you use copper metal, here you can see in this picture copper rod dipped in silver nitrate solution. Okay, the copper rod which is in red color and silver nitrate a solution which doesn't has any color, but blue color starts developing. How? You can see in the intermediate stage the solution of color becomes little bit blue. Okay, now intensity of blue color increases. How? Yes, how? Here the solution develops blue color due to formation of Cu plus 2 ions. Okay, so here you can see Cu is oxidized to Cu plus 2 and Ag plus is reduced by 2 electrons. So means reduced mean was, we know reduction, that is the accepting 2 electrons. So the 2 Ag plus is becoming Ag. Okay, so here Cu, that is the copper, is oxidized to Cu plus 2 and Ag plus is reduced to Ag. Now let's see the equilibrium greatly favors to the product Cu plus 2 and Ag. Okay, you can see the equilibrium, that is the reaction is balanced. Now here one more situation, when we put this comparison of reactions of metallic cobalt placed in nickel sulfate. Okay, so what happened? You can see again cobalt releases 2 electrons and becomes Co plus 2, and nickel accepting 2 electrons and becoming Ni. So at equilibrium you can see here there is no products are greatly favored. So what we can say from this here? So we can say this competition of releasing of electrons are nothing but the competition of releasing protons. Okay, so here I wanted to say, by comparison we have come to know that zinc releases electrons to the copper and copper releases electrons to the silver. So therefore the electron releasing tendency of the metals is, it has an order. So what is the order? Zinc gives more, means readily. Okay, readily gives to the electrons to the copper and copper gives to the electrons to the silver. So you can see the order. So first will come zinc, then copper and then silver. Okay, so in this way, from this video we can conclude that there is an order to follow when we are doing the redox reactions. So here I wanted to say, by finishing this video, thanks for watching and do subscribe my channel for more videos.